In this video, I'll show you how to solve the ALEKS problem called Interpreting the Radial Probability Distribution of an Orbital. This is going to give us the probability distributions of 3 different orbitals. It's going to ask us the same 3 questions for every single variation of the problem. The first question is asking us to determine the most likely distance for an electron in a particular orbital. I'm being asked specifically about orbital B. It's not always going to ask you about orbital B, so definitely pay attention to that. The most likely distance from the nucleus for each one of these orbitals is represented by the highest probability point. So for the blue orbital on my graph, this is the most likely distance, or this point corresponds to the most likely distance. And for my green, this is the highest probability point of my green orbital. So this would be the most likely distance for my green orbital. And then for my red orbital, the highest probability point is right around here. And again, this is the axis that gives me probability, so I'm just looking at the highest point of each one of these different graphs. I have been asked about B, which is green. That looks like it's about 275 picometers. ALEKS gives you quite a bit of wiggle room with that measurement. Second question, you're going to be asked to list the orbitals in order of increasing energy. The energy of an orbital increases along with its distance from the nucleus. So the further an orbital gets from the nucleus, the higher in energy it gets. So the ones that are close to the nucleus or have a low distance from the nucleus, those are the low energy orbitals. And then on this side of the graph, the ones that are further away, those are the high energy orbitals. We're listing them in order of increasing energy, which is going to be blue, green, red. My blue orbital is C, and my next one is B, and then A. And if you're wondering again, what am I looking at, because they all kind of span this whole distance, I'm looking at the high probability point for each one of these graphs. That's the only thing that you're going to focus on for each one of these graphs. The only part that you're paying attention to is the high probability point. So my high probability points, comparing those 3 points, that's how I come up with this ranking. Then last but not least, it's asking which orbital of these 3 would be the most effective at screening the charge of a nucleus from an outer electron. And that is always going to be the one that has the highest probability closest to the nucleus, smallest distance from the nucleus. So the one that has the probability that is closest to the nucleus, that's going to be the one that's the most effective at screening. For me, that is the one represented by blue, which is C.